Question 6. So this particle is moving in a straight line, but if you go and look at the formula for x, the equation for x, it's a cubic, so it's something like this. So 3 times it's passing the same point, it's passing O. 3 times it is no distance from O, so it's doing something like this. It's sort of oscillating, it's going backwards and forwards and backwards, so bear that in mind. So part 1, the velocity and the acceleration of p when t equals 0. Well, this is distance, this x displacement is distance, so v is the velocity is the rate of change of distance, so we have to differentiate this. So obviously multiply by the power, reduce the power by 1 for each of these 3 terms, giving us dx dt being this. We're trying to work it out when t is 0. So when t is 0, we substitute 0 into this, and we get v being minus 0.24 meters per second. Secondly, we've got to work out the acceleration when t is 0. Well, acceleration is the rate of change of velocity, so we have to differentiate again. So we're now differentiating the velocity with respect to t. So we're differentiating this, giving us this. Again, we substitute t being 0 in, and we get acceleration being minus 0.9 meters per second squared. Now, for part 2, we're asked the value of x when p has its minimum velocity and the speed of p at this instant. So let's just consider minimum velocity, so our velocity. Well, our velocity equation is a quadratic, so, and it's a positive t squared, so it's sort of the smiley face one. So at minimum velocity, this is going to be when dv dt equals 0. So in other words, when the acceleration equals 0, because dv dt is acceleration. So we're trying to solve this when acceleration, so 0.36 t minus 0.9 equals 0. So that allows us to work out that t is 5 over 2. Now we need to then work out both the velocity and the speed. The value of x has its, and the speed of p at this instance. So we need to work out the value of x and the speed when t equals 5 over 2. So the value of x, the displacement, so we're just going to substitute 5 over 2 into this, which I've done here, giving us minus 2.475 meters. And secondly, so we've just done the value of x, we've now got to find the speed, so that we substitute 5 over 2 into our speed equation, so into this. So substituting 5 over 2 into this gives us a velocity of minus 1.365. Now remember, speed is just the modulus of this. Speed is just a number. Velocity is this, but our speed is 1.365. So it's important that your speed you give as a positive. However, your x, your displacement, you must give as a negative, because this is not asking for the distance, it's asking for the displacement. So that has direction as well as magnitude. Now for part 3, the positive value of t when the direction of motion of p changes. So let's think about this. It's going backwards and forwards. So at the second that it changes direction, that's when it's just momentarily stopped. So we're trying to solve for when v equals 0. Now this is our equation for v. So we need to solve this quadratic equaling 0, so we just use our quadratic formula. So a is 0.18, b is minus 0.9, c is minus 0.24. Pop that into the quadratic formula. We only want the positive value, so that's why I haven't got plus or minus here. I'm just having the plus option, and popping that into a calculator, we get 5.25 seconds.